We're looking at a Verizon wireless plan that has 900 monthly minutes for $59.99. If you go above 900 minutes, it's going to charge you 40 cents extra, the company is. So we want to write a linear function that gives the monthly price to a person as a function of the number of minutes used above 900. So if you don't use any minutes above 900, if it's 0, then your total price will be $59.99. If you use 10 minutes over, let's say, then you're going to pay $59.99 still, but now you're going to have to add on to that 40 cents 10 times because you're using 10 extra minutes and it's 40 cents per extra minute. So notice that all we're really doing here to get P is taking $59.99 and adding to it 40 cents M times, depending on how many minutes you use above 900. Now this isn't the number of minutes you talk, this is the number of minutes above 900. Now we want to find and write P of 100. Well, P of 100 means if you use 100 overage minutes, you're going to pay $59.99 plus 40 cents times 100 minutes, and that will give you, that's going to be $40 more you're going to have to pay for those 100 minutes. You might want to up your plan, but that would be $99.99 for 100 overage minutes. In part C, we want to write an equation that describes the total number of minutes used in the given month. Call this function T of M. Okay, well, this seems weird because isn't M the number of minutes? Well, M is the number of overage minutes. So in fact, if you use 0 overage minutes, that means you've, well, we're assuming that you've used 900 minutes of your plan. Otherwise, you probably wouldn't buy it. If you use 10 overage minutes, then your total minutes used would be the 900 plus the 10 minutes that you went over. So you used a total of 910 minutes. Well, how do we get this? To get the total minutes you use, take the 900 of the plan plus the number of overage minutes. And so if we wanted to find and interpret T of 100, T of 100 would mean, okay, if I use 100 overage minutes, that means I have to, in total, I've used 900 plus 100 is 1,000 total minutes. Well, now we want to look at the relationship of these functions. So write a new equation, call it A, which is going to be the total price of your monthly bill divided by the number of total minutes you use. So all we really have to do here is take this function and divide it by this function. So P divided by T, so this is what we're calling A. Well, your price is $59.99 plus the 40 cents per minute, and your total minutes is 900 plus M. And so now the question is, find and explain the real-world meaning of A of 0, A of 10, A of 100. What do you notice? Okay, well, A of 0 is, well, what do we get when we plug in 0 for M? Well, we're going to get $59.99 plus 0.4 times 0 divided by 900 plus 0. So notice this is the total price, this is dollars, and this is the number of minutes that you've used in total. So in this case, we'll have $59.99 divided by 900, so this is dollars over minutes, so guess what our units are going to be? Dollars per minute. This comes out to about a roughly $0.07 per minute. Okay, well, I'm just going to jump straight to A of 100. So this is 7 cents per minute on average. Now, if I use 100 minutes of overage, that's a lot, right? Well, 100 minutes of overage is going to be $59.99 plus 0.4 times 100. So we know that your total price is going to be $99.99. That's dollars, so this is dollars up here. And the total minutes that you've used is the 900 of your plan plus 100 overage minutes, which puts you at 1,000 minutes. So guess what happens to your average price? Well, it goes up. It goes up to 0.099 repeating, and this is dollars per minute. So you're basically paying 9 cents per minute now, and guess what's going to continue happening? Your average price per minute is going to continue to rise. So that's what we're noticing here. And the question is, well, how long will it continue to rise? Well, the vertical asymptote is going to be M equals negative 900, because that's what's going to make the denominator 0. Now, we know that that's not possible, so we can pretty much ignore the asymptote. The horizontal asymptote, based on the order of the function, will be, the orders are the same, so our ratio of the m coefficients will be 0.4 over 1, and that means we're going to average. Now we're noticing that as the number of minutes increases, the average, so in this case we're looking at the average really, that's what A represents. It's in, the outputs are in dollars per minute, and so we notice that, at least we noticed for, from 0 to 10, the price increased from 7 cents to about 9 cents per minute, and then we have this asymptote over at 0.4. So up here is 0.4 somewhere, and we have this horizontal asymptote. So as the number of minutes increases, it must be approaching that asymptote, roughly like this, and we're going to graph it to see. And then our vertical asymptote is somewhere over here at negative 10. So basically, if you continue to sketch it, it would look pretty much, it'd be shaped pretty much like all the other ones we've looked at, except we're looking at the graph below the vertical asymptote. Why are we doing that? Well, because whenever you're talking about 0, or when you're talking about a positive number of minutes, it seems that the output values were all below that asymptote. So 0.07, that's for 0 minutes. That's your vertical intercept. 9 cents a minute, that's 100 minutes later. Or if you've used 100 minutes, not 10 minutes. So this would be 100. But as you continue to use more and more minutes, your average price is actually going up. Well, that must be because of the fact that whenever you use just your plan, $59.99 divided by 900 minutes only comes out to 7 cents per minute. But now you're incurring 40-cent additions for every additional minute you add as overage, and so naturally your average is going to go up. It's going to approach 40 cents per minute because this term will dominate. If you use 1,000 overage minutes, then these two numbers really don't make that much of a difference. They start to become a smaller part of the equation, and so we start to notice something that looks like this. Now we could graph this in our graphing calculator. I'm going to do this in a website that's called wolframalpha.com, and so what I will do is I will just enter in parentheses these two equations. So I'll do 59.99 plus 0.4 m, and then I'll divide that by 900 plus m. So there is my equation, and I will just hit enter and just see what Wolfram Alpha produces. This is a really powerful engine that will show us things graphically, and it shows us one graph, but we're not really satisfied with that. So let's do this. Let's say at the very beginning of this, I'm going to write plot, and I want to plot this function from m equals 0 to m equals, let's say theoretically 10,000 overage minutes. Now that would mean you probably are talking too much, but let's just take a look at what this would indicate. And there it is. So we can see that as we use a few number of minutes, our average price is really low, but as you use more and more overage minutes, your average is getting closer to that overage charge on average. And so that's kind of what we see here. And so our asymptote is right above here, and our vertical asymptote is back here, kind of the way we sketched it.